Count good triplets. Given an array of integers and three integers a, b and c, you need to find the number of good triplets. A triplet array, which are nothing but the numbers in the array at index I, j and k, is good if the following conditions are true. So the first condition is I, j and k, the indices has to be in increasing order, strictly increasing, and all of them have to be in the range of 0 to array length. Okay, and the other conditions are pretty simple to understand. So the difference between the number at index I with the number at index j in this array has to be less than or equal to a. Okay, and similarly the number at index j and the number at index k, their difference has to be less than or equal to b, and similarly for c. Now this is pretty simple conditions. These are simple conditions, but what makes this problem a little tricky is this condition. That they have to be in increasing order, right? Let's understand using this example. Let's consider this array with A, B, and C. Our index I, j, and k has to be in increasing order, and what we want is, so the absolute difference between the numbers at each of these index, right? So 3 minus 0, the value is 3. 3 is lesser than a. Of course, the first condition is that. The second condition is j, the value at index j and value at index k, they are absolute difference, which is 1. Okay, 1 is less than or equal to 2. Second condition also satisfied. And the third condition is I and k, right? So 3 minus 1 is 2. 2 is less than or equal to 3. Of course it is. So we found our first triplet. Okay. Now let's increment our k to the next location, and if you notice, it's the same one here. Okay, and again all of these conditions will be satisfied, and we found our second triplet. Now notice the triplet is 301, 301. They are duplicate of each other, right? So in that case, what we can conclude is we can have duplicate count. Okay, the only thing is we don't have to count our same index twice, right? We can have different indices but same elements. Okay, hope that makes sense. Now let's move on. What the question asks us is return the number of good triplets. So all of the count of the triplets, that's what we have to return. So the answer is pretty simple. The thing is, you have to think in terms of brute force way. So what's a brute force way? The thing is, we consider our same array again, and what we can do is we can have our I, j can be I plus 1, and it can run from I plus 1 till the end of the array, and k from j plus 1 till the end of array. Okay, and that way we can continuously keep on iterating till the next element, till we reach end of the array, and we can keep on checking those conditions and validating whether we have a good triplet or not. And yeah, so that way I think we can proceed. J will then go to the next location, and k will start from j plus 1 till the end, right? So that way we can do, but the time complexity for that solution will be O of n cube, right? And sure, it's very easy to code that out. You can try it out, but what we are going to explore in this video is the optimal way. So we can make few observations. Consider this number line. Consider this number line. So let's put our array j, the number, okay, the number at array j location at this location, okay, in the number line. Now we can have our a, okay, so if you consider this first condition, okay, our array I minus array j should be less than or equal to a. What observation can you make from this? Well, if we have this value a either in this place, suppose it's at this distance away from array j, the number, okay, if it is at this distance away, okay, then we can have our array I, this number, anywhere between this location. You need to understand this, very important. Why? Because just if you put your array I, any number which is within this range will definitely make the difference between array I and array j lesser than a, right? If suppose where the cursor, okay, at this location is our array I, that number, okay, array I, if at this location of the cursor is our array I, okay, then the difference, okay, this whole difference, okay, till the cursor will be lesser than our this whole range, right? So that's what. So we can put our array I in any of these places, okay? And similarly, since it's an absolute difference, we can put it here as well, okay? So we can put it in this entire range, anywhere in this entire range to satisfy this condition, okay? So what I mean is, array I can be less than or equal to array ij plus a, okay? It can be less than or equal to this location, or it can be less than or equal to this entire location, right? This entire range, okay? It can fall to only satisfy this condition. Now let's consider our array k at this location, all right? And if we consider second condition, we can formulate the similar example, okay? If we want to satisfy only this condition, we can place our c at this location and we can figure out array I, that number at index I, anywhere between this range, right? And similarly, we can have our array I even at this range, okay? So this entire range can be home to our array ith number, right? And that will satisfy only this condition. That is very important, only this condition, okay? And similarly, we can formulate the same observation, array I is less than or equal to array k plus c, that is this entire thing, or it is array I less than or equal to array k minus c, or this entire location, right? Now, if we want to simultaneously satisfy these two, okay, and but before that, what I want is to satisfy this as well. Let's assume that the distance between array j to array k is b, or at least within the range b, okay? So this is like less than or equal to b. Let's consider, okay? We'll make that that is the condition that we'll have to check, okay? There's no way out from that, but here we are trying to figure out an alternative way, okay? And this we have to check. So let's just say that these are within the range of b, okay? Then yeah, so the third condition also is satisfied, right? So in that case, how are we going to simultaneously satisfy all these three conditions? In that case, can you, okay, can you put your array I here? Because if you put your array I here, you will be able to satisfy this first, but will you be able to satisfy the second? The answer is no, you won't be, right? And the second thing is, you can put it over here, okay? Your array I, that number can lie between this range, but will it satisfy this? Again, it won't, right? So what we want is, we want this overlapping range, okay? If we have our array I, that number, in this range, only then we can absolutely say that it satisfies all these three conditions, right? You can make out, because if my array I is here, then it is less than a. If array I is here, then it is obviously less than c as well, right? So that is the main observation that we make in this problem. Now let's look at this number line a little closer, okay, and figure out if we have some edge cases. Now let's have array j here at this location and array k at this location, and let the difference, the distance between them be b or less than or equal to b. Okay, this we have to check. Okay, now what we can do is have our a at this location, or we can have our a at this location, as I mentioned in the previous slide. Now the thing is, even array k can have c at this location, or array k can have c at this location. Now can you tell me, is there a number I that satisfies this condition as well as this condition simultaneously? Does it? The answer is no, it can't. Just it's simple to understand. See, if you have an array I here, okay, first of all, can you have your array I here the way I was saying that the range has to be overlapping? The thing is, the range is not overlapping here at all. Okay, so that's why you can't have your array I here at all, because these are disconnected ranges, right? This is separate, this is not overlapping. So it means we can't have it here, right? Because this won't satisfy either of the condition. If our array I is here, then array I is greater than A and it is greater than C as well, right? And similarly, if you have your I here, array I here, that number, then it will definitely be satisfying this condition, but it will never satisfy this condition. And same applies to this range. So in this case, we don't have a solution. All right. Now let's consider another edge case, okay? And we'll have our array j here and array k over here, and let's have the difference between them b as previously. Now let's consider k first, okay? So k's bound is c, right? So let's have our c at this location, okay? So this entire location, if we place our I anywhere, then it will satisfy our second condition, that is our I minus k, array I minus k will be satisfied, right? We can have array I at any of these locations to satisfy that, and we can have over here as well, right? Now to satisfy j, array jth condition, the first condition, we can have our a here or we can have our a here. Now tell me, to satisfy both of these conditions, where should our array I lie? It can't lie here, because it's you might say that they are overlapping, but they are not, okay? The range is over here. The first condition's range is over here, and the second condition's range is like this entire thing, okay? Here it will satisfy the second condition, this one it will satisfy, but it will never satisfy this, okay? And you can't even think about this entire range, because it's like totally out, it's not even overlapping. But here, if you can put in this entire range your array I, then you do have a solution, okay? So what do you conclude from this? You conclude that you will have a range first of all, and you have to figure out the bounds of the range. The bounds of the range will be, right, will be minimum of array j plus a and array k plus c. What is it? Array j plus a and array k plus c, the minimum of those, okay? And it's this, because we don't want this, because we want the minimum of these two, the right, okay? And similarly, we want our left bound, okay? And that is this and this. So in this case, what it will be? It will be maximum of these two. Why? Because if we have c here and a, we want to figure out which comes later. A comes later, right? So yeah, so these are the two main conditions. If you understand this part, your main headache is solved for this problem. Now finally, what remains is, how are we going to keep track of all the values that are coming in array I, the location, okay? And again, that array I ith index has to be lesser than j index. So it has to be previous value, right? So how do we know we have visited a value previous to the jth index? Okay. And also it has to lie in this left and right range. How do we keep track of that? So the answer is simple. We'll use prefix count. Now, if you don't know what prefix count is, I'll just briefly explain what we are going to do. So I'll take the same example with same ABC values. What I'm going to do is, as soon as I visit my j, so I'm obviously going to have two iterations, okay, two for loops nested. And for j, the first for loop, okay, the jth location, as soon as I visit my jth location, okay, I understand that this is my first location. Now from j to the maximum value, that is 9, that is present in this array, okay, till there, till then, okay, from 3, okay, so array j is what, 3, right? So from 3 to the maximum value, that is 9, I am going to increment the prefix count, okay, 1 1 1, okay, this is what I mean, okay. And this array is already populated, but I am not going to like populate it right in the beginning. We are going to populate it within the algorithm, like right when the algorithm is running, okay. So what we are going to do, again I'm going to explain this 3, okay. So array j value is 3, j is 0, but the value at array j is 3. So I'm going to the array, okay, prefix count array at this location, and I'm going to increment it to 1. So initially this entire thing will be initialized to 0, okay. So at this location I'm going to go and increment it to 1, okay, and then next value from here I'm going to increment to 1, and next value to 1, okay, and till the end, okay. So for this, what I have to do is I have to first of all initialize this prefix count to 0. I have to figure out this maximum value, okay, and then initialize it inclusive of the max value, okay. So from 0 to 9, that is 10 locations in my array. The length of the array will be 10. So for 3, I have to do run it from 3rd location till the 9th location and increment it by 1, okay. Now why am I doing this? Because at this 3, okay, I have found a value that is greater than, that is lesser than this, that is lesser than and equal to this particular index in my prefix count. So 3 is lesser than equal to 3, is lesser than equal to 4, is lesser than equal to 5, and we have already encountered this, okay. Now let's go to array j for better understanding. Array j equals to 1, okay, this location. So this is 0, right? So here I am going to increment it to 1, and here I am going to increment it to 1. Here also I am going to increment to 1. Now this will be incremented to 2. Now an entire thing, okay, till here will be incremented to 2. Now what does this mean? When I reach j equals to 1, I already have at this location seen 3, right? But 3 is actually greater, right? So at 0th location, all I have is the count of all the values which are lesser than this 0th location, okay. But when I reach this, only then I am going to increment it to 1. But before that, it was already 0, okay. So that's what I'm going to do. And then I have to do this while I'm running the algorithm, because I don't want to encounter numbers which come later. For example, 3 and 0, okay. 0 comes later, okay. 3, after 3. So of course we are going to increment this to 2, okay, because we have encountered a number which is lesser than 3, but it comes later, right? So when we are running for 3, we won't be noticing any 0, it will be still 0, okay. Now you can do it yourself, run through the entire array and check what we'll get for the prefix count. But this is a short brief on the prefix count. Now let's code it out. All right, so what we will start with is we'll first find the max value because we want to initialize our prefix count array. Okay, so we need to make this minimum, but since our constraint here satisfies 0 to 1000, our array I will be from 0 to 1000, we can simply just take 0 here. Okay, and for I in range of length of array, we can simply just figure out the max value using max method, max value comma array I. Okay, so this will give the maximum value in our array, and then we can initialize our prefix count value array, which will be initialized to 0 and which will run from max value, 0 to max value plus 1. So I want the max value inclusive. From suppose max value is 9, right? So from 0 to 9 inclusive. So our length will be 10, right? So the max value being 9 plus 1, 10. So the length will be 10. Now once this is done, we'll focus on our algorithm now. So for j in range of length of array minus 1, we are not going to consider the last value obviously because our last value is retained for k, right? And for k in range of length of array, so this will go from j plus 1 to length of array, right? Okay, and for each of these value, first of all, we need to satisfy this second condition, don't we? So that's what we are going to do. If absolute value of array j minus array k is less than or equal to b, only then proceed. Okay, so now here what are we going to do? We are going to find our right and left range, okay, the range in which our array I is going to fall on, right? So what we'll do is right equals to, now this is minimum as we saw earlier, right? So we need to find minimum between array j plus a and array k plus c, right? So minimum of those. So array j plus a comma array k plus c. So once we have minimum of those, we will be satisfied. But we also want to make sure that this number that we are going to get doesn't like cross our maximum value. Okay, it's not greater than our maximum value. So in that case, we will keep a bounce check here. It has to be minimum of right comma max value. Okay, once we have this, then we are sure that we will never go out of bounds in this prefix count. Okay, and similarly we'll figure out left bound, and here in this case we need maximum, right? So maximum of array j minus a comma array j minus c. Okay, once we have that, again we want to make sure we don't go into a negative value, right? So in that case, all we have to do is keep a bound minimum, right? Minimum between left comma 0. Okay, that way we are sure that we'll never cross 0, right? And then the another edge case that we saw was the overlapping of the intervals, right? So left has to be less than and equal to the right, right? Only then we can figure out the array I number. Otherwise, there is no solution for that, right? So what we finally do is we will figure out. Well, we finally have found our triplet, right? So I'll initialize a result which will keep track of the count, right? So that will be incremented. And how will it be incremented? Here we will use our prefix count. Prefix count. And what will come here? Well, we need, so what our prefix count stores? It stores all the values which are less than or equal to this number, okay, the current number, which is our right, okay. So at this location we will have all the numbers that are lesser or equal to this number, right? So once we have all the numbers which are lesser than or equal to this number, we can just increment it over here. But what this will include is all the from 0 to this right number. We will have all the numbers which are we will have the count of all the numbers which are lesser than or equal to this number, right? So what we want to do is minus prefix of left minus 1. Why? First of all, why prefix of left? Why we are minusing? Because we don't want to the count of the numbers which are beyond the left bound. We have a bound here, right? We want it. We want the count of the numbers which fall within the right and left range. Okay, only those. That's why we are subtracting. And why this minus 1? Because left is inclusive, okay? So we want all the numbers, the count of all the numbers which are within left and right, okay, inclusive within the range, okay? So we are going to subtract all the numbers which are lesser than this left minus 1, okay? Hope this makes sense. And this also can fall in out of index problem if we have 0, right? With 0 minus 1, so minus 1, right? So what we can do here, we can make a condition 0 if left equals to 0, else this is the solution, right? Ta-da! We have finally done this. Now the only thing that remains is populating our prefix count array. So how are we going to do that? Well, as I mentioned in the explanation, what we are going to do, we are going to run from our in range from array j from this jth location, right? So the current location that we are in till the max value plus 1, right? We're going to run through our array, like till our array, and we can actually take this length of the array as well, but let me keep this simple so that you understand that this is max value plus 1, max value inclusive, right? So we are going to run through this, and what we are going to do is we are going to increment the prefix count at each of this location by 1. Okay, that's it. That's the whole algorithm. And then finally all I have to do is return my result. Let me check if this works. Sorry, I have done a mistake here. So I need a max max value and max value here as well, right? Now I have sorry, prefix count. Again here prefix count instead of prefix. done. So this is the solution and this is the final solution. I made some silly mistakes, please forgive me for that, and thank you so much for sticking around for so long. Bye.